Start recording. There we go. Given the following data, which of the following precipitates would form first upon drop-wise addition? Drop-wise addition just means you add it one drop at a time. Okay? So what we have then is we have a situation where we have 4 test tubes. 1, 2, 3, 4. And we add 1 drop to the first test tube. And we add 1 drop to the second test tube. AgCl. Oops, sorry, this is Cn minus. Cn minus, Cl minus, Br minus, and I minus. Now, at some point, like probably nothing happens upon the addition of the first drop, but maybe in the second drop, we get a precipitate forming, but it will only form in one of them. Okay? And we want to know which one does the precipitate form first. So we have information. The concentration of the Cn and the Cl, the Br and the I are all the same. The concentration of the Ag that's being dripped in is all the same. KSP basically tells you how big the hotel is. The bigger the KSP, the bigger the hotel. At least as long as they are all 1-to-1 or all 1-to-2. Okay, they all have to be the same ratio. But these are all 1-to-1 salts. So which hotel is the biggest? AgCl is the biggest hotel. So you'll be able to add the most drops of silver before a precipitate starts to form. Which hotel is the smallest? AgI, which means that you will add the smallest number of drops of Ag before a precipitate starts to form. It takes the fewest number of drops. So who will form the precipitate first? AgI, because it is the least soluble salt. Other questions? Yes. The next one, number 4. Okay, yep. What is the maximum concentration of Mg? So the concentration of Mg is what we don't know. We know the concentration of carbonate. That is 5.0 times 10 to the minus 1. And we know that the KSP is 2.5 times 10 to the minus 5. And we can write a KSP for MgCO3, and that is equal to concentration of Mg2 plus times the concentration of CO3 2 minus. Yes? So we know this value. We know this value. And this is the one that we don't know. So let's solve for concentration of Mg. Concentration of Mg 2 plus is equal to the KSP divided by the concentration of CO3 2 minus. So that's going to be 2.5 times 10 to the minus 5 divided by 5.0 times 10 to the minus 1. And we get 0.5 E5 negative divided by 5 E1 negative equals 5 times 10 to the minus 5. So that would be B. Is that good? Just isolate the one that's unknown. Yeah. So anytime when you have a minimum or a maximum, isolate the one that's unknown and then plug in the numbers. Yep. Good stuff. Yes, Samira. Number 6. Yeah. Which one of the following will result in the formation of a precipitate of silver chloride when solid NaCl is added to a solution of silver nitrate? So the product of the molar concentrations of silver and chloride, what that means is we're taking the concentration of silver and multiplying it by the concentration of chloride. Okay. If that is less than KSP, will we get a precipitate? No. No precipitate will occur unless the solution becomes saturated with NaCl first. Does that sound like it makes any kind of sense? No. So it's not that one. The product of the molar concentrations of silver and chloride exceeds means is greater than. And if you come across that on a test and you're like, I don't know, what is this exceeds business? You can ask me, is greater than the KSP, will we get a precipitate forming? Yes. Okay? And then I think probably the concentration of aqueous sodium is greater than that. That's just irrelevant. Like B and D are just silly answers. Yeah. Yes. 20. And Jody, which one did you want? 52? Okay, so 20 and 52. Okay, so here we have number 20. And we have 2 equilibria here. Notice this says referring to question number 20, so make sure you look at it. If we added sodium chromate, what would that do to our lead chromate equilibrium? It would shift to the left because we've increased the chromate, which would cause it to shift to the left, and that would not cause it to redissolve more. That would cause less of it to dissolve. Okay? Now, what if we add dichromate, Cr2O7, 2 minus? Well, that's going to affect our second equilibrium. It will, cause it to shift to the left, which will cause chromate ion concentration to increase, which will cause this to shift to the left, which means that less is dissolved, not more. So far, so good? Okay. A strong acid. Let's clean it up so we can take a look. That contains H+. So that would increase the concentration of H+, which would shift this to the right. What are we doing with chromate if we're shifting this to the right? We're using it up. And that means chromate concentration is going to decrease, which means that the first equilibrium here is going to shift to the right, which means more of it is dissolving. So it's this one. Is good? Okay, 52. Okay. Oops. Okay, a student mixes equal volumes. Whenever you see equal volumes, what's happening is you are doubling the volume, right? Because let's say I started with 100 milliliters of each. then my final volume would be 100 plus 100 is 200 milliliters. And it doesn't matter what volume I start with. I could start with 35 milliliters. And when I add the two together, I will have 70 milliliters. What I end up with is 1/2, right? So if it doubles the volume, that means the concentration is halved. Halved. Okay, so my concentration of lead then is equal to 0.002 times 1/2, which is 0.001. My concentration of iodide is 0.004 times 1/2 is 0.002. Now I have lead iodide, which is PbI2. So that's going to dissociate into 1 lead and 2 I minus. So our KSP then is lead times iodide squared, which is going to be 0.001 times 0.002 squared. 0.001 times 0.002 squared equals 4 times 10 to the negative 9. And hopefully that's one of our answers. Yes, it is. A. Yes. 48. Yep. From the list of salts below, how many are considered soluble at 25 degrees Celsius? So let's go and look at our solubility table. So we've got copper and chloride. Now it was CuCl2. Do you remember on the quiz I was really mean? That one where we wrote the precipitation reactions. This is copper 1. Yes? But we have CuCl2, so that is copper 2. Okay, so this is soluble. One of the others was calcium sulfate. That is low solubility. Let's go check out the other ones. So this one is soluble. This one is low solubility. I'm pretty dang sure that lead sulfide is low solubility, and almost all phosphates are low solubility, and almost all silvers are low solubility. So I'm guaranteeing you that this is going to be a low solubility. So how many are considered soluble? 1. I mean, you can double check those on the table, but that's the results you'll get. Number 8. Yep. Okay, so we have 30 milliliters of 8 times 10 to the negative 8 molar calcium. So our concentration of calcium when it is diluted is 8 times 10 to the negative 8 molar times our old volume, 30 milliliters, over our new volume, which is going to be 30 plus 10 is 40 milliliters. And that's going to give us 6 times 10 to the negative 8 molar. Sodium fluoride, concentration of fluoride is going to be the same as sodium fluoride diluted because they're 1 to 1. NaF, 1 fluoride in there. So we now have 3 times 10 to the negative 2 molar times 10 milliliters divided by 40 milliliters as our total volume. 3 divided by 4 is 7.5 times 10 to the negative 3 molar. Calcium fluoride is a 2-to-1 salt, CaF2, Ca2 plus 2F minus. So our KSP then will be calcium times fluoride, and my concentration of calcium is 6 times 10 to the minus 8. And the concentration of fluoride is 7.5 times 10 to the minus 3. I forgot a square here. Sorry about that. That should be squared. So that's going to be 7.5 times 10 to the minus 3 squared. And we get 6e negative 8 times 7.5 e negative 3 squared equals, I get 3.4 times 10 to the negative 12. So that's going to be C, and let's just double check that a precipitate does not form. Yeah, it is smaller. 10 to the negative 12 is smaller than 10 to the negative 11. So a precipitate will not form. (13) Pardon me? 15 and 16? Okay. Okay, so number 13, we have silver acetate, AgCH3COO. Solid is in equilibrium with a saturated solution, Ag plus CH3COO minus. Which would cause more AgCH3COO to dissolve? So we want to shift this equilibrium to the right. Okay, so you can either understand this question and sort of see like the little cross unit problem here, or you can do it by process of elimination. Okay, either way will work. What we've got to start with is we've got silver nitrate, so we would be increasing silver, which would cause it to shift to the left. So that would not cause more to dissolve. So A is wrong. Nitric acid, we have H plus and we have NO3 minus. Do either of those react with anything in our products? The acetate. Acetate is a weak base. Okay, so this is where it's like, oh, that's our other unit coming into play here. So you will have CH3COO minus plus H plus gives us CH3COOH. So what are we doing to acetate? We are using it up. Okay, so that's going to cause this to decrease, which will cause this to shift to the right. Now, if you happen to see that, that's fantastic. Otherwise, you can say, oh, I don't know, it doesn't seem to do anything to me. But you can find that definitely this one would, it's got that common ion, so it would decrease the solubility, and then evaporating some of the water would not cause more of it to dissolve. So by process of elimination, you're left with B. Okay? Yeah. Yeah. 26. Oh, and we wanted 15 and 16. And 26. Okay, 15. A solution contains barium, lead, iron, and magnesium. Whoa, okay. Barium, lead, iron, magnesium, which would cause a precipitate with only one of those metals. Iodide. Okay, let's go look and prove that I'm right, okay? It's because I know that lead is one of the very, very insoluble ones. So let's go look at this. Iodide precipitates very little. Yes, it only precipitates silver, lead, and copper. So if I wanted to precipitate only one of those, iodide would do it. Okay, sulfate would precipitate, I think, the lead and the, well, nitrate precipitates nothing. And phosphate precipitates almost everything. Except for like alkali ions, and none of these are alkalis. And the only other one is sulfate, and I think it precipitates both the barium and the lead, but let's double check. Sulfate. Yeah, barium and lead are both precipitated by sulfate. Okay. The equation for the dissolving of silver sulfate in water is as follows. If silver sulfate is in equilibrium with a saturated solution, which would result in more dissolving, so we want this thing to be shifting to the right. And if we add H2SO4, we are increasing the concentration of SO4, which would shift this to the left. So that's no good. If we add more silver sulfate, does adding more solid change anything? No. No change. Adding silver nitrate, that's going to cause our silver ion concentration to increase, which will cause it to shift to the left. Add chloride, which, oh, they were so nice to tell you that. I could have even thrown that in there without saying which precipitates silver chloride and had to look it up. Okay, but if chloride precipitates with silver, you're going to have these two guys reacting to form AgCl, solid, which uses up the silver, which causes silver concentration to decrease, which will cause it to shift to the right. Number 18 as well, sure. 18, we're still holding on to number 26, we're getting there. Okay, what is the maximum? Oh, look at this, we've got maximum. Magnesium, so this is what we don't know. We know that the concentration of OH minus, there's only one OH in there, so that's going to be 1.0 times 10 to the minus 3. We know that the KSP is 1.2 times 10 to the negative 11. And we're wondering, what is the concentration of magnesium? So if we write our KSP expression, well, let's start by doing MgOH 2 in equilibrium with Mg 2 plus 2 OH minus. Okay. So KSP is equal to Mg times OH minus squared. And we want to find the magnesium concentration. So we can solve for magnesium. So that's going to equal KSP over the hydroxide ion concentration squared. So we would have 1.2 times 10 to the negative 11 divided by 1.0 times 10 to the negative 3 squared. So that's going to be 1.2 times 10 to the minus 5. So that's going to be B. Yeah? Okay, number 26. Consider the following, which would increase the solubility. So we want to shift 26. That's 25. I'm so sorry. Thank you. I can count. Sure, I can. Okay, equal volumes. So once again, we have these equal volumes. And what happens to the concentration when we add equal volumes? We have doubled the volume, so we've halved the concentration. Okay, so this is going to become 0.1 molar, and this is going to become 0.1 molar, and 0.1 molar is a special concentration. Why is 0.1 molar a special concentration? Okay. 0.1 molar means it's going to be soluble. Okay, so we're looking for something which is soluble. Or something which is not soluble, actually, because we want to see if a precipitate forms. So we're basically looking to see who is, let's see, we would have our outside ions, calcium hydroxide, and we would have our inside ions, strontium sulfide. So let's look up calcium. I believe calcium hydroxide is low solubility. And strontium sulfide, I don't know off the top of my head, so let's go look it up. Strontium sulfide is soluble. So we would get a precipitate of calcium hydroxide. Is good? Yes. 11. Okay. Which of the following is true about mixing equal volumes? Oh, look, equal volumes. That means what do you do with the concentration? Half the concentration. So this is going to become 0.01 molar, and this is going to become 0.0002 molar. And we are concerned here about well, it's certainly not the sodium chloride, is it? Right? Because sodium and chloride are both mostly sodium soluble with everything. So we're looking at the calcium with the sulfate. Oh, and they tell you it's calcium sulfate even, so you didn't even have to know that. So our KSP is equal to, because it's 1-to-1, it's going to be calcium times sulfate. And so that's going to be 0.01 times 0.0002, which is 0.01 times 0.0002 equals 2 times 10 to the negative 6. 2 times 10 to the negative 6 is smaller than times 10 to the negative 5. So this is actually, I'll write trial here. So if you ever forget to write Q and you write KSP by mistake instead, you can always just stick a trial in front of it and it becomes Q. So if you're like me and you always forget, just stick a trial in front of it and you're good to go. So the trial product is smaller than KSP, and if it is smaller than KSP, then a precipitate will not form. Okay, so there's our answer there. Number 29. Did you have a question as well? No? Okay. 29. Did you like how I did that, Isaac? 29. Yes, I know, right? Okay. All right. Oh, look, what number do we have here? 0.1. Where should we be looking? On our solubility chart. So basically this is asking if you can produce at least 0.1, that means it is soluble. And in fact, we don't even need to look at our chart. Which of these salts is soluble? The one that contains the alkali. Is good? Yes? 24. Mm-hmm. Which of the following reagents? A reagent just means a reactant, okay? Does that answer your question? Maybe not. Half of it, okay. So a reagent is just a reactant. Which of the following reagents could be used to indicate the presence of calcium? So we're looking to see who causes a reaction with calcium, okay? So who is going to precipitate with calcium? So we have sulfide. We have nitrate, because it's a positive ion, it'll react with the negative ions. CO3, 2 minus, and acetate, CH3. Well, this one also has calcium, so that's a stupid choice, right? So we're going to say no to that one right off the bat. We're going to say no to nitrate, because nitrate doesn't react with anything. So we would need to look up sulfide and carbonate and see who precipitates with calcium. So sulfide does not precipitate with calcium. So it would not tell us whether calcium is there, but carbonate will. It's in the all others, so it's going to be that one. Okay? Yes? 57. You betcha. 57. Okay. Shush, shush. Oh. Okay. Yes. Yeah, of course. Okay, so we have COCl2 and is dissolved. So it dissolves and makes CO2 plus and 2Cl minus. And the concentration of COCl2 is 0.35 moles in 100 milliliters. So that's 0.10 liters. So that's going to give us 3.5 molar. Okay, so we have 3.5 molar for the cobalt chloride, which means that cobalt is 3.5 and chloride is 7.0, because it's twice as much, because it's got that coefficient of 2.
Number 64.
64. The following solutes are given. Which of the solutes listed will form only molecular aqueous solutions? So, how do you know if something is ionic? That's the easiest way.
Metal.
You either have a metal or you have
A non-metal.
and it starts with a metal or NH4. So, out of these choices, who is ionic? 1 and 3 are ionic, and therefore the other ones must be molecular. So that would be 2 and 4 only. There we go. Yes? 9. Sorry, 9? 39, yes. Okay, once again, we have an ionic solution here that we're looking for. In order to be ionic, it needs to start with
Metal or NH4.
metal or NH4. Yes. Okay, so who starts with the metal? CaNO3 2. All the rest do not have metals. So this one is ionic. The rest would be molecular. Okay? Yep. And 40? Yep. Zinc hydroxide. Ooh, look! All over the place. What number am I seeing that's making me happy? 0.1 molar. So where should I be looking? I should be looking on my data booklet to see, is zinc hydroxide soluble or low solubility? I believe it's low solubility. Let's just double check. Hydroxide, all others. Zinc is not there, so it is low solubility. And if it is low solubility, we cannot make more than 0.1. So less than 0.1. Okay, if you're soluble, you can make more than 0.1. But if you're low solubility, you cannot. That's the definition of soluble. Okay? Yes. 69 and 70. Yes. Which of the following salts has the highest solubility? All right. Well, they all contain silver, so let's look at our anions and see if any of them stand out immediately. Bromate, bromide, chromate, nitrate. Nitrate. Nitrates are soluble with everything, which means it will have the highest solubility. So that was 69. Lowest solubility. Well, it's definitely not going to be calcium nitrate, right? Okay. Calcium chloride is soluble. Yeah, acetate's also soluble with everything. So acetate is soluble with everything. So not that one. So we're down to calcium chloride or calcium carbonate. And if we look on our data pages, carbonates are low solubility with just about everything. So calcium carbonate is going to be low solubility. Chlorides are soluble with almost everything except for these three guys. Cap, copper, silver, lead. And so it's going to be the carbonate. Yes. 77, 78. Yeah. And Samira, what were you looking for? 72. Okay. Here, we'll go in order. Why not? What the heck? Which of the following has the lowest concentration of carbonate? Well, what do you know about ammonium salts?
Soluble in everything.
NH4 salts are always soluble. So it's not going to be that one because that's going to have a high concentration. So we're looking for magnesium, calcium, and strontium. And carbonate is one of the things that has low solubility with just about everything. So if we go and look at carbonate, calcium, strontium, magnesium, they're all down here. So that's not helpful to us. So we're going to have to look at our KSP values. And in fact, I'm going to bop over here because I already marked them in block 7. So we have magnesium carbonate has a power of 10 to the negative 6. We have strontium carbonate has a power of 10 to the negative 10. And we have calcium carbonate, which has a power of 10 to the negative 9. So which one is the least soluble? 10 to the negative 10. So it's going to be your calcium, or your strontium carbonate will have the lowest carbonate concentration. Yeah. Okay, and where did we go? Here we are. 77. Ooh, solubility. Nice. So we have barium chromate, which dissociates into barium 2+, and chromate 2-. And let's let X equal the solubility. Yes. Which means this is X and this is X. Yeah. And so now it's going to be KSP is equal to X squared, which is 1.1 times 10 to the minus 5 squared. That's going to be this one. There we go. Yeah. Cadmium carbonate, also a 1-to-1 salt, CdCO3. Solid, la 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 la. Cd, 2+, CO3, 2-. KSP, oh, let the solubility equal X. So we have X and we have X. So that is X squared. And the KSP is 1 times 10 to the negative 12. So that's equal to X squared. So X then is equal to 1e12 negative square root 1 times 10 to the negative 6. And that is moles per liter. Yes, because that always gives us moles per liter. But these units are grams per liter. So what we have to do then is we have to change it to grams. The molar mass of cadmium carbonate is, cadmium is 112.4, 112.4 plus 12 plus 16 times 3 is times 172.4 grams per mole. And that gives us times 1e6 negative equals 1.7 times 10 to the negative 4.
For this one, we can like square it, and then the other one we can square it. Like this one.
Because for here, we're given for this one, we're like, what is the value of KSP? So we're substituting for X because we know what the solubility is. We know the solubility. This one, we're finding the solubility. So we're solving for X. So it just depends what you're substituting for and what you're solving for. Yeah, that's right. Yeah. ¿Algo más? Yes. 81. What is the value of silver concentration in saturated silver chromate? So we have Ag2Cr04, solid, in equilibrium with 2 Ag plus Cr04, 2 minus. Okay. What do we have here? We have, well, in this case, let's let X equal the solubility of Ag2Cr04, which means that this here is X and this is 2X and this is X. Okay, you don't have to do all of this if you know that KSP is equal to 4x cubed. You can do it if you need to, but you can just say, okay, it's equal to 4x cubed. And I know the KSP because I can go look it up in the data booklet. Silver chromate, 1.1 times 10 to the negative 12. 1.1 times 10 to the negative 12 equals 4x cubed. Do you guys want me to show you the algebra or just go for the money? Okay, so x then is equal to, let's see, 1.1e12 negative divided by 4 equals cube root 6.5 times 10 to the negative 5. And now we have to ask ourselves, is that what we were asked for? We were asked for the concentration of silver, which is 2x. So concentration of Ag plus is 2x, which is 2 times 6.5 times 10 to the minus 5, which is 1.3 times 10 to the minus 4. All right, how are we doing? 105, yeah. By the way, if I were you all, if I had any masks at home, I'd be wearing them for the next few days. Everybody seems to be sick. So, all right. And wash your hands. Calculate the concentration in molar of iodide ions in a saturated solution of lead iodide. So lead-2 iodide is PbI2. Yes. Yeah. Pb2 plus 2I minus. And if we want to find the concentration of iodide, that's going to be 2x. This is going to be x, and this is going to be x. So we're really finding the solubility, because if we find the solubility, we can find the individual ion concentrations. Okay, so we have KSP is equal to 4x cubed. All right, so we now have 1.39 times 10 to the minus 8 divided by 4 is equal to x cubed. So x is equal to 1.39 E8 negative divided by 4 equals cube root 1.5 times 10 to the minus 3. And now you say, what was I asked for? I was asked for the concentration of iodide, and iodide is 2x. So 2x is the concentration of iodide, is 3, approximately 3 times 10 to the minus 3. And it's going to be that one. Huh? 103 and 104? Yeah. 103, 104? Okay, cool. 103. In which of the following solutions would we expect AgBr to have the highest solubility? So we want that equilibrium shifted to the right. So we don't want anything that has silver or bromide in it, right? Yes? Sure. Because if we have silver or we have bromide, those are going to shift it to the left. So no silver, no bromide, bromide. Oh, okay, so we're not shifting to the right, we're just not shifting left. Okay, so it's pure water. Yeah. Oh, you would look and you would have to say if there was something else that precipitated silver, it could shift it to the right. If there was something else that precipitated bromide, like say we added some lead, that would precipitate the bromide and that would shift it to the right. So something that will decrease the concentration of silver or decrease the concentration of bromide by reacting with it. Yeah. Okay, and 104, we want the lowest solubility, so we want it shifted to the left. PbCl2, PbCl2, Pb2 plus 2Cl minus. Oh my gosh, everybody has chloride or lead. Yes? So everybody's going to shift this to the left except for pure water, so we can eliminate pure water. Who's going to shift it to the left the most? That's going to be the one with the highest ion concentration. Concentration of chloride here, it's 1 to 1, so that's 0.20 molar. Concentration here, it's 1 to 1, so that's 0.015. Sorry, there should be a 0 in there. Concentration here, oh, there's a 2. So that's going to be 0.04 molar, and this lead is 0.015. So who has the highest concentration of one of these two ions? It's going to be the barium chloride. We'll shift it the most to the left. Yes? 63. Iron Sulfate, we have 0.25 moles in 500 milliliters of solution. So the concentration of Fe to SO4 3 is 0.25 moles in 500 milliliters, which is 0.5 liters. So that is 0.25 divided by 0.5, which is 0.5 molar. Now, if we draw out the Fe2, SO4, 3, you can just look and you can say, okay, iron is going to be twice that because I've got 2 of them. Right? So that's going to be 0.5 times 2 is 1. And sulfate is going to be 3 times that much because I've got 3 of them. So that's going to be 0.5 times 3 is 1.5. A 100. Excellent. Lowest solubility, so we want it shifted to the left. L for lowest, L for left. Hey, look at that. That's nice. And I'm sorry, I forgot all my little molarities. So that should say molar, that should say molar, that should say molar. So we're looking for things that will increase the concentration of silver or increase the concentration of chloride. Oh, look, silver, chloride, chloride, chloride. So how am I going to tell which one will make it have the lowest solubility? The one with the highest concentration. Who has the highest concentration? BaCl2, because we've got 2 Cl's, so the concentration of Cl is 0.04 molar. Mm-hmm. $99, yes. What is the solubility of SRF2? SRF2 is in equilibrium with SR2 plus 2 F minus, and we're going to let X equal the solubility. This is a 1 to 2 salt, so because this is multiple choice, you can just say KSP is equal to 4x cubed. If you're not comfortable with that, you can say, okay, let this be x, this is x, and this is 2x, and then I can say KSP is equal to strontium times fluoride squared, and that's equal to x times 2x squared, and that's where we get the 4x cubed from. Okay, and now we need to go look up our KSP from the data booklet. Strontium, what did I just do? Strontium fluoride, 4.3 times 10 to the minus 9. 4.3 times 10 to the minus 9 divided by 4 is equal to x cubed. 4.3 E9 negative divided by 4 equals cube root. X is equal to 1.02 times 10 to the negative 3. So that would be D. Ten from the written? Yep. Show by calculation and state whether or not a precipitate of barium sulfate will form when 1.50 grams of K2SO4 is added to 2 liters of 1.70 times 10 to the negative 5 molar BaCl2. So we want to know barium sulfate. So barium sulfate, solid equilibrium, Ba2 plus SO4, 2 minus, aqueous. Aqueous KSP is equal to the concentration of barium times the concentration of sulfate. And because I've been asked whether or not a precipitate will form, that means I actually want to do Q. Okay, so I'm going to just stick a trial in front of here because I forgot to make it a Q. All right. I know the concentration of barium. Concentration of barium is the same as the concentration of barium chloride is 1.70 times 10 to the minus 5. Concentration of sulfate, well, there's one sulfate in every one K2SO4, so that's going to be equal to the concentration of K2SO4. And I have 1.50 grams in, and I've dissolved it in that 2 liters of solution, so that's per 2 liters. And I don't want it in grams per liter, I want it in moles per liter. So I need to cancel my grams and find my moles. The molar mass of K2SO4, potassium is 39.1 times 2 plus sulfur 32.1 plus 4 times 16 equals 174.3 grams per mole. So 1.5 divided by 2 divided by 174.3 equals 4.3 times 10 to the minus 3. 4.3 times 10 to the minus 3. And we multiply that by 1.7 times 10 to the minus 5. And we get 7.3 times 10 to the minus 8. K trial, which is 7.3 times 10 to the minus 8, is bigger than KSP, which is 1.5 times 10 to the minus 9. They've written it up here for us. And therefore, a precipitate will form. Good stuff.
I'm 67.
67? The following represents the equilibrium in a saturated solution of iron 2 fluoride. In a saturated solution of iron 2 fluoride, the fluoride concentration is 1.68 times 10 to the negative 2 molar. What is the molar solubility of FeF2? Now, this is a 1 to 1 to 2 So this is going to be 2 times as much as this one. Yes? So this is 2x, this is x, and this is x. So x is equal to 1.68 times 10 to the minus 2 divided by 2. So that would be 8.4 times 10 to the minus 3. Did I do that right? No, I did not. Did I? 1.6. Oh, there's a typo for C? Oh, yeah, that's right. There's a typo for C. This should say -3. That's why. Fix. Well, you guys have successfully fended off learning anything new today. Well done. Give yourselves a pat on the back. Anyone got any more questions before we call it a day? Okay. Good stuff. I got me some fixing to do in here so that it won't have those errors next year. Yay.
You're welcome.
Oh, I can do that.
Yeah.
It just depends whether, like in the situation where we had one there, like you didn't have to do it, then you could add a solid, right? But if you mix 2 solutions, then you have to do it. Yeah. Oh, mix 2 solutions. What? Yeah. You're happy. The outlier, bigger than 0.2. Or you can just look at it and be like, Mr. Clark, not very far.
The students better, students not better.
Oh, you guys get your whole quiz back today, right? Yes, so if you did not get your entire quiz back last day, you get your entire quiz back today. I'll find you a copy of it, okay? G1, Ryu, Aaron, Jody. Sarah's not here. G1 on. Copeland, Michelle. Hiya. Jinya. Hannah. Right there. Hiya. Jinya. Hannah. Isaiah. Jonathan. And that's it. Everyone else should have theirs already. Is that the case?
Thank you.
Ellie, yours is, you didn't get yours back yet, right? No, because you're in with my other block for some silly reason. Where are you? There you are. There you go. Okay. Now, we're going to steal one here. You wanted what? Question 2? 3.
So it's a type 2 question.
What is maximum concentration? It's type 3.
As a reminder for grade 12 students, the school leaving ceremony extra tickets
right? So what we're saying is we're saying, I want to find the concentration of hydroxide and I know the concentration of KS and I know KSP and I know aluminum. Yeah? Yeah. Hi. Let's go put it on your desk. Yes, right there or over there. Yeah. Hi. Yes. Increase the solubility. You can shift to the right. Oh. Decrease solubility, shift to the left. So if you add silver, it's to the left. If you add permanganate, it's to the left. Add silver, it's to the left. If you add iodine precipitate with. Okay, right? With silver, that will decrease the silver and we'll shift it to the right. Yes. KSP doesn't change and you want to change the temperature. Bye.
Thank you, Mr.
You're welcome, Aaron. See ya. Like 2 molar, it has to be soluble. Carbon chloride. Bye. Beryllium chloride is soluble. All the rest of them, no solubility. It just means that if something is soluble, you can make a solution that is greater than 0.1 molar. Yeah, the reason you circled chloride is because you saw this copper, but that's only copper 1. What kind of copper do we have? We have copper 2+. So it's probably going to be sulfide, I'm guessing. Sulfide is soluble with manganese and calcium. But what solubility with copper? Are you just waiting, or do you have a question? You have a question? Okay. Because she might be wild. She got a lot. Yeah. Yeah. You just check for the home contents, okay? Yeah. You want something to precipitate both calcium and magnesium. Precipitates both. Because it wants to precipitate calcium and magnesium. So that means both. Oh. Oh, sulfate doesn't precipitate magnesium.
Oh, I was looking for that. Okay. Yeah.
Mm. 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 Okay. 1661, which of the following ions to be added to lead and barium to precipitate one of them? Iodide precipitates only lead. You've got the answer right there. Right? Because this precipitates none of them. So you want to separate them by precipitating. That means precipitate only one. This precipitates both. This precipitates both. That doesn't separate them. Yeah? Yeah.
And then like one more.
Okay, so chloride is one of the ions that would cause it to shift to the left. Right? It's, you know, this was silver. This would be silver chloride, right? Okay, so chloride will cause it to shift to the left. Chloride will cause it to shift to the left. Silver will cause it to shift to the left. D does nothing. So the first three make it less soluble, and the last one does nothing, so it will be the most soluble in D, because it doesn't make it less soluble.
Is it the liquid so hot in this test?
Like this?
Yeah.
It'll be like this, yeah.
Is there like right hand respond like have like so many fractions?
14 marks between 4 and 6 questions. Just depends on how many marks there are per question.
I did all calculations.
Nope.
How many calculations?
I don't know. It depends on what version you get.
Oh, we have 2 versions.
Well, I just don't know which version I'm going to use yet.
Oh.
Right?
Okay.
I have several versions. They're all the same difficulty, but okay. Yeah. Okay, 83. Increase by adding HCl. So hydrogen reacts with hydroxide. I wonder why. Because hydrogen and hydroxide are make water. It's a neutralization. So they will have a reaction, so that will decrease the concentration of hydroxide, which would make more of the salt dissolve. Okay. So greater than 0.1 molar means it needs to be soluble. Because that's an alkali. Yeah. Okay, so if you add KBr to saturated AgBr, what will happen is oh, good. Yeah, you can just toss it in there. Perfect. Thank you. And, oh, I should stop recording. Everything's been recorded. Stop.